Hello, everyone, and welcome to our presentation on IoT protocols for healthcare, transportation, UAVs, UUVs, and smart buildings. My name is Joseph Maruf, and I'll be presenting alongside Alejandro Calderon as part of our CNT 4165 course. Today, we're diving into the fascinating world of IoT, the Internet of Things. IoT represents a network of interconnected devices that communicate and share data to improve efficiency, productivity, and safety. It's a technology shaping the future across various industries. In this presentation, we'll explore 5 key sectors where IoT protocols are making an impact. And those are healthcare, transportation, unmanned aerial vehicles, also known as UAVs, unmanned underwater vehicles, also known as UUVs, and smart buildings. Each sector faces unique challenges and opportunities, and IoT protocols are at the core of solving them. Healthcare is one of the most transformative fields for IoT technology. Through connected devices, IoT enables continuous health monitoring and real-time data collection, which has revolutionized how we approach patient care. Wearables, such as fitness trackers and smartwatches, can monitor vitals like heart rate, blood pressure, and even blood oxygen levels. These devices provide real-time insights that can help detect potential health issues early, improving patient outcomes significantly. Another key application is remote patient monitoring. For patients with chronic conditions, IoT devices allow for consistent tracking without the need for frequent hospital visits. Doctors can monitor a patient's condition from afar and intervene promptly if needed. This not only reduces the burden on healthcare facilities, but also enhances the convenience and quality of care for patients. Telemedicine, powered by IoT, has also been a game changer. It bridges gaps in access to care, particularly in underserved or remote areas, by enabling virtual consultations and remote treatments. This means patients can receive expert medical advice from the comfort of their homes without the challenges of travel or limited access to specialists. Overall, IoT in healthcare not only improves outcomes for patients, but also reduces operational costs for healthcare providers. It brings efficiency to diagnostics, treatment, and patient management, making healthcare more accessible, affordable, and effective for everyone. While IoT offers remarkable benefits in healthcare, it also brings critical challenges, especially when it comes to security and privacy. Healthcare data is highly sensitive, and ensuring its protection is not just important, it's essential for maintaining trust between patients and providers. Let's dive into how IoT security is addressed in healthcare systems. First, secure communication protocols are at the heart of protecting patient data. These protocols ensure that data transmitted between devices, healthcare providers, and cloud systems remains encrypted and secure. For example, data from a patient's wearable device, like a glucose monitor, is encrypted before being sent to their doctor's office. This prevents unauthorized access during transmission. One innovative approach to security is the use of biometric authentication, such as the combination of EEG signals and fingerprints. This two-stage method provides an extra layer of protection. Here's how it works. EEG signals, which are unique to each individual, are captured and analyzed for identification. Once the EEG is validated, the system requires a fingerprint to complete the authentication process. This ensures that only authorized users can access sensitive medical data. These security measures aren't just theoretical, they have real-world applications. For instance, they can be used to secure remote patient monitoring systems where patients share live health data from their homes. Biometric authentication can also protect access to electronic health records, ensuring that only verified healthcare professionals can view or update them. Another critical area is data privacy. Patients need to trust that their personal health information is safe and will only be used for medical purposes. IoT systems that comply with privacy regulations like HIPAA to ensure confidentiality. This involves not only encrypting data but also implementing strict access controls and audit trails to track who accesses the data and when. Finally, real-time processing is a cornerstone of IoT healthcare applications. Imagine a remote monitoring system detecting a patient's heart rate spike. It needs to alert the doctor immediately. Security measures must work seamlessly without delaying these time-sensitive processes. Striking the right balance between security and performance is a key challenge for IoT developers. In summary, IoT security in healthcare is about safeguarding sensitive data, ensuring privacy, and maintaining trust. With robust communication protocols, advanced biometric authentication, and compliance with privacy regulations, healthcare IoT systems can deliver both innovation and security. As IoT adoption continues to grow, these protections will be critical for enabling safe and effective patient care. Transportation systems are evolving rapidly thanks to IoT. By connecting vehicles, infrastructure, and users, IoT enables smarter, safer, and more efficient transportation networks. Let's take a closer look at how IoT is reshaping this sector. One of the most impactful applications of IoT in transportation is fleet management. Companies can use IoT devices to track their vehicles in real time, monitor fuel usage, and analyze driving behavior. These insights help optimize routes, reduce operational costs, and improve overall efficiency. For instance, a delivery company can adjust its routes dynamically based on real-time traffic data, saving both time and fuel. Traffic control is another area where IoT makes a significant difference. Smart traffic lights powered by IoT can adapt to changing conditions by analyzing data from sensors and cameras. For example, during rush hour, these systems can adjust signal timings to alleviate congestion on busy routes. This not only reduces travel time but also lowers vehicle emissions, contributing to a greener environment. In public transportation, IoT has revolutionized the passenger experience. Sensors and IoT-enabled devices track bus and train locations in real time, providing accurate updates to commuters. Mobile apps can alert passengers about delays, available seats, or alternate routes, making their journeys smoother and more predictable. For instance, many cities now offer real-time bus tracking through IoT, ensuring passengers aren't left waiting at stops unnecessarily. The benefits of IoT in transportation extend beyond efficiency. Safety improvements are a major focus as well. IoT devices in vehicles can monitor critical systems like brakes and tire pressure, alerting drivers to potential issues before they lead to accidents. Additionally, connected devices can communicate with each other to prevent collisions, especially at intersections or during lane changes. Energy efficiency is another important advantage. IoT solutions help reduce fuel consumption by optimizing routes and traffic flows. Electric vehicles integrated with IoT systems can monitor battery levels and locate the nearest charging stations, ensuring smoother operations and a more sustainable future for transportation. In summary, IoT is transforming transportation by enabling smart fleet management, improving traffic controls, and enhancing public transit. Its applications lead to reduced travel times, greater safety, and better energy efficiency. As IoT continues to integrate into transportation systems, we can look forward to even smarter, more connected networks that benefit both individuals and communities. The NGSI protocol is at the forefront of IoT innovation in transportation, providing a robust framework for data modeling and communication in smart systems. Let's explore how this protocol enhances transportation systems and improves the user experience. NGSI, or Next Generation Service Interfaces, is specifically designed to manage dynamic real-time data. It excels at integrating static information, like bus routes, with dynamic updates, such as vehicle positions or service alerts. This capability is critical for modernizing public transportation systems and making them more responsive to real-world conditions. One standout feature of NGSI is its integration with the GTFS-RT, or General Transit Feed Specification for real-time. GTFS is widely used for transit data, but NGSI extends its capabilities by adding real-time context. For example, NGSI enhanced systems can provide live updates on bus locations, passenger counts, and even arrival times. This integration creates a seamless flow of information that benefits both operators and passengers. A practical example of NGSI in action is in Rome's public transportation system. By adopting the NGSI protocol, the city has significantly improved efficiency and user satisfaction. Passengers receive real-time updates on bus schedules and delays, while transit operators gain actionable insights into system performance and passenger demand. This level of connectivity ensures smoother operations and a better overall experience. Another strength of NGSI is its ability to model both static and dynamic data properties. Static properties, like bus stop locations, are stored alongside dynamic ones, like vehicle occupancy or current speed. This view enables smarter decision-making from route optimization to fleet management. To simplify integration, NGSI uses tools like GTFS-RT to NGSI-LD mapping tool. This tool makes it easier for existing systems to adopt IoT capabilities, reducing the need for extensive infrastructure changes. In summary, NGSI is a game-changing protocol for smart transportation. By enabling real-time data exchange and integrating seamlessly with existing standards like GTFS, it empowers transportation systems to be more efficient, reliable, and user-friendly. With NGSI, cities like Rome are setting the standard for IoT-enabled transit and its potential for future advancement. Unmanned aerial vehicles, or UAVs, have become a vital part of modern technology, playing a transformative role in industries like logistics, disaster management, and surveillance. IoT integration takes these capabilities to the next level by enabling real-time data exchange, efficient operations, and improved decision-making. Let's explore how IoT powers UAVs. First, IoT protocols enable real-time data sharing, which is critical for UAVs to perform their tasks effectively. For instance, in disaster response scenarios, UAVs equipped with sensors can gather data about damage, locate survivors, and transmit this information to rescue teams in real time. This speeds up response times and enhances situational awareness in life-saving operations. Another key application of IoT in UAVs is efficient routing protocols. UAVs rely on optimized flight paths to minimize energy consumption and maximize delivery speed. IoT systems calculate these routes dynamically by analyzing environmental conditions, obstacles, and traffic patterns. For example, a UAV delivering medical supplies to a remote location can adjust its route mid-flight based on real-time weather updates, ensuring the fastest and safest delivery. In logistics, IoT-enabled UAVs are revolutionizing last-mile delivery. Companies like Amazon are using UAVs to deliver packages directly to customers, leveraging IoT for tracking, navigation, and customer notifications. These systems not only enhance efficiency, but also reduce the environmental impact of traditional delivery methods. Surveillance is another area where IoT-integrated UAVs shine. By using sensors and cameras, UAVs can monitor areas for security or environmental changes. For instance, UAVs can survey large agricultural fields, identifying pest infestations or irrigation needs. The real-time data is then transmitted to farmers, enabling quick and precise interventions. Overall, IoT enhances the situational awareness of UAVs, making them smarter and more autonomous. This capability is essential in applications where quick, data-driven decisions are needed, such as monitoring traffic or inspecting infrastructure. These UAVs rely heavily on IoT protocols that support communication, sensing, and data processing. Alongside these advancements, UAVs face significant challenges, particularly in terms of security and energy efficiency. To start, communication frameworks are essential for UAVs to function as part of a network. These frameworks enable drones to exchange data with each other and with ground control stations. For instance, UAVs in a swarm operation must coordinate their movements and share sensor data in real time. This is achieved through advanced IoT protocols that ensure seamless connectivity and collaboration. Security is one of the biggest challenges in UAV operations, particularly due to the open nature of wireless communication. UAVs are vulnerable to threats such as hacking, spoofing, and data interception. To address this, protocols like blockchain are being integrated into UAV networks. Blockchain ensures data integrity and secure communication by creating an immutable ledger of all transmitted data. This makes it nearly impossible for unauthorized parties to alter or intercept information. Another approach to UAV security is the use of hyperelliptic curve cryptography, which provides high levels of encryption with minimal computational overhead. This is particularly important for UAVs as they operate in resource-constrained environments and cannot afford to use protocols that consume too much energy. Speaking of energy, battery life is another critical factor for UAVs. Since most drones are battery-powered, they need to optimize energy to use to maximize their operational time. IoT protocols play a key role here by enabling energy-efficient communication and routing. For example, instead of broadcasting data continuously, UAVs can use smart protocols to transmit only essential information, conserving power. Despite these advancements, challenges remain. For example, ensuring real-time performance while maintaining strong security can be complex. Additionally, the need for lightweight protocols that balance energy efficiency and processing capabilities continues to drive research and development. Unmanned underwater vehicles, or UUVs, are transforming the way we explore and manage our oceans. These robotic systems, equipped with IoT technologies, enable us to conduct tasks that were previously impossible or too dangerous for humans. From monitoring marine environments to extracting resources, UUVs play a vital role in underwater exploration. First, UUVs are equipped with advanced sensors and cameras that collect critical data about underwater conditions. These include parameters like water temperature, salinity, pressure, and even pollution levels. This data is invaluable for monitoring marine life, studying ecosystems, and assessing the impact of human activities on the ocean. One of the most significant applications of UUVs is in resource extraction. For example, UUVs can be deployed to locate and assess underwater mineral deposits or inspect subsea oil and gas pipelines. Their ability to operate autonomously in extreme environments makes them ideal for these tasks. Surveillance and security are other key applications of UUVs. These vehicles are used to patrol maritime borders, monitor underwater infrastructure, and detect illegal activities such as smuggling or unregulated fishing. The use of IoT in these operations ensures that UUVs can communicate and relay data to control centers in real time. Despite their capabilities, UUVs face several challenges. Communication is a major hurdle, as underwater environments often disrupt traditional wireless signals. To overcome this, UUVs rely on acoustic communication systems, which use sound waves to transmit data. While effective, these systems are slower than traditional wireless communication, limiting the amount of data that can be sent in real time. Energy efficiency is another challenge. UUVs require significant power to operate their sensors, cameras, and propulsion systems. IoT protocols help optimize power usage by enabling energy-efficient data collection and communication. To address security and resource management concerns, blockchain technology is being integrated into IoT-enabled UUV systems. Blockchain ensures secure data sharing and resource allocation while supporting autonomous decision-making. For instance, a UUV could decide to change its course or prioritize certain tasks based on pre-programmed conditions. Blockchain technology is emerging as a vital enabler for IoT and UUVs. These vehicles operate in some of the most challenging environments on Earth, where secure and reliable data exchange is essential. Let's explore how blockchain is addressing the unique needs of UUV operations. First, blockchain provides secure communication. In underwater environments, traditional wireless networks are often unreliable due to interference and limited range. Blockchain offers a decentralized system for data storage and sharing, enabling that all transactions and information exchanges are tamper-proof. This is crucial for missions like underwater surveillance or resource exploration, where data integrity is non-negotiable. One of blockchain's most powerful features is its use of smart contracts. These are self-executing contracts with terms written into code. In a UUV context, smart contracts allow vehicles to make autonomous decisions based on real-time data. For instance, if a UUV detects a significant environmental anomaly, it can autonomously reroute itself to collect more data or alert nearby stations, all without human intervention. Blockchain also enhances resource management in underwater IoT networks. UUVs often operate in resource-constrained environments where energy and computing power are limited. By leveraging blockchain, UUVs can prioritize tasks, optimize energy use, and share resources efficiently across the network. This ensures that missions are completed effectively even with limited resources. However, blockchain's integration in UUVs is not without challenges. Connectivity is a major limitation in underwater environments. Acoustic communication, while effective for transmitting data underwater, has low bandwidth and high latency. This can slow down blockchain transactions, making real-time operations more difficult. Researchers are working on solutions like lightweight blockchain architectures to address these issues. Another challenge is the computational demand of blockchain. Mining and maintaining a blockchain network requires significant energy and processing power, which are scarce in UUVs. To overcome this, more efficient consensus algorithms such as proof of stake or delegated proof of stake are being explored to reduce the resource burden on UUVs. Smart buildings are at the forefront of innovation using IoT technology to enhance energy efficiency, improve security, and automate processes. These buildings integrate sensors, actuators, and intelligent systems to create environments that are not only efficient, but also responsive to occupants' needs. Let's explore how IoT is transforming building management. One of the key features of smart buildings is energy management. IoT devices continuously monitor energy consumption across systems like HVAC, lighting, and appliances. By analyzing this data, smart buildings can optimize energy use, reducing waste and lowering costs. For example, occupancy sensors can detect when rooms are empty and adjust lighting or temperature settings automatically, ensuring energy is used only when needed. Security is another critical aspect of IoT in smart buildings. IoT-enabled security systems include features like smart locks, video surveillance, and access control. These systems can monitor entry points in real time, send alerts for unauthorized access, and even lock down specific areas during emergencies. Data from these systems is stored securely, ensuring that privacy and safety are maintained. Automation is where IoT truly shines in smart buildings. With IoT-based building management systems, or BMS, devices can communicate with each other to streamline operations. For instance, temperature sensors can trigger window shades to close during peak sunlight hours, maintaining indoor comfort while reducing cooling costs. Similarly, IoT systems can automate water management by detecting leaks and shutting off water supply to prevent damage. IoT also enhances occupant comfort. Sensors that monitor air quality, humidity, and noise levels ensure that indoor environments remain pleasant. For example, smart air purifiers can activate automatically when air quality drops, creating a healthier living or working space. Despite these benefits, integration challenges remain a key concern. Smart buildings often involve a wide variety of devices from different manufacturers, which can make it difficult to ensure compatibility. IoT solutions need to be scalable and flexible enough to integrate diverse systems while supporting future expansions. The backbone of any smart building is its IoT protocols. These protocols enable seamless communication between devices, sensors, and systems, making it possible to optimize energy use, enhance security, and ensure smooth operations. One of the standout protocols in smart buildings is LoRaWAN, which stands for Long Range Wide Area Network. LoRaWAN is specifically designed for low-power, long-range communication, making it ideal for buildings with a large number of sensors spread across multiple floors. For example, LoRaWAN allows temperature sensors, lighting systems, and HVAC controls to communicate efficiently without consuming much energy. Its ability to cover long distances ensures that even devices located in remote parts of a building remain connected. Advanced sensors and controllers play a significant role in smart buildings, and they rely on these protocols for real-time data transmission and control. These sensors monitor parameters like temperature, humidity, lighting, and air quality, while controllers use this data to optimize building performance. For instance, a smart thermostat can adjust heating and cooling based on occupancy patterns, reducing energy consumption while maintaining comfort. Despite these advancements, integration challenges remain a hurdle. Smart buildings often involve a diverse array of devices from different manufacturers, each with its own communication protocol. Integrating these systems into a unified network requires careful planning and compatibility solutions. Protocols like LoRaWAN help by offering a standard framework, but full interoperability still requires ongoing development. Another challenge is scalability. As smart buildings grow in size and complexity, their IoT networks must scale to accommodate additional devices and higher data loads. LoRaWAN addresses this by supporting a high capacity of connected devices, but network design must still account for full future expansions to avoid bottlenecks. Security is also a vital consideration. Protocols must ensure that sensitive data, such as access control logs or energy usage patterns, are transmitted securely. Features like encryption and secure key management are integral to preventing unauthorized access and maintaining occupant trust. Let's take a moment to compare the IoT protocols we've discussed and understand how they cater to the unique needs of different sectors. While every industry leverages IoT protocols for connectivity and efficiency, the specific requirements of each sector dictate the design and functionality of the protocols they rely on. Starting with healthcare, protocols like MQTT are often used for their lightweight nature and ability to handle small data packets efficiently. Healthcare applications demand real-time data exchange for monitoring and diagnostics, but security is paramount. Protocols here focus on encryption, authentication, and data privacy to protect sensitive patient information. In transportation, NGSI-LD stands out for its ability to manage context data, integrating static information like schedules with real-time updates like vehicle positions. This combination makes it ideal for dynamic systems like public transit, where efficient data handling and interoperability with existing systems are key. UAVs, or unmanned aerial vehicles, require protocols that emphasize low latency and high reliability. Real-time operations are critical for tasks like surveillance and disaster response. Additionally, protocols for UAVs must be energy efficient due to their resilience on battery power. Security also plays a major role, with blockchain and advanced cryptographic methods ensuring data integrity and secure communication. For UUVs, or unmanned underwater vehicles, the primary challenge lies in communication. The underwater environment imposes limitations on bandwidth and connectivity, making acoustic communication systems essential. Blockchain-enabled IoT protocols are often used to provide secure data exchange and resource management, ensuring reliable operations even in resource-constrained environments. Finally, in smart buildings, LoRaWAN is the protocol of choice for its low power consumption and long-range capabilities. It allows a vast number of sensors and devices to communicate effectively, supporting applications like energy management and security. Scalability and integration remain important considerations as these systems grow more complex. In summary, while all these protocols share the goal of enabling efficient and reliable IoT systems, they are uniquely tailored to address the demands of their respective industries. Healthcare prioritizes security, transportation focuses on real-time data, UAVs and UUVs emphasize reliability and energy efficiency, and smart buildings demand scalability and integration. As we've seen throughout this presentation, IoT protocols are the foundation of innovation across multiple industries. From healthcare and transportation to UAVs, UUVs, and smart buildings, these protocols enable devices to communicate, share data, and operate efficiently. They are critical for addressing the unique challenges of each sector while unlocking new possibilities in the future. In healthcare, IoT protocols ensure secure and real-time data exchange, improving patient outcomes and expanding access to care. In transportation, protocols like NGSI transform public transit and fleet management systems, making them more efficient and user-friendly. For UAVs and UUVs, IoT protocols provide the secure communication, energy efficiency, and autonomous decision-making necessary to operate in complex and challenging environments. Finally, in smart buildings, protocols like LoRaWAN enable energy efficiency, security, and automation on a large scale. Each of these sectors has unique requirements necessitating tailored protocols. However, they all share common challenges: the need for scalability, interoperability, and above all, security. As IoT adoption continues to grow, research in lightweight, energy-efficient, and secure protocols will be critical to addressing these challenges. Looking to the future, IoT protocols will continue to evolve alongside advancements in technologies like blockchain, AI, and 5G. These developments promise to make IoT systems even more reliable, efficient, and adaptive. For example, integrating AI into IoT networks could enable predictive maintenance and smarter resource allocation, while blockchain could further enhance data security and transparency. In conclusion, IoT protocols are not just shaping the present, they are paving the way for the future of connectivity by enabling smarter systems and better decision-making. They are driving efficiency, productivity, and innovation across industries. As these protocols evolve, we can expect even greater breakthroughs that will redefine how we live, work, and interact with the world around us. Well, that wraps everything up. Thank you for your attention throughout this presentation. I hope you guys found everything interesting and insightful. Feel free to leave a comment and we will reply within 24 hours. And have a wonderful day. Goodbye.